So we look at the factor theorem. So if for a polynomial px, pc equal to 0, then x minus c is a factor of px. If for a polynomial px, pb over a equal to 0, then ax minus b is a factor of px. So we don't go to very complicated thing. Okay, I just show you a very simple example here. Okay, if we have a polynomial x that is x minus 3 and 2x plus 5. Okay, this is a quadratic equation. Okay, but it is power 2 lah. It is also a polynomial. Okay, for this one, what is the root? So we have the root is x minus 3 equal to 0, then x equal to 3 ma. Then we have the 2x plus 5 equal to 0, then x equal to negative 5 over 2. Okay, for this one, x equal to 3 and x equal to negative x over 2, 5 over 2 is the root. Then we have p3 is 3 minus 3, 2, 3 minus plus 5. Then it is 0. Okay, because this is 0. 0 times a number, then will become 0. Okay, so if we have the p negative 5 over 2, then we have the 5 over 2 minus 3, and the 2 times 5 over 2 plus 5. And this is negative 5 over 2. Okay, then this part will become 0. So this is 0. So 3 is the root. So we have a trick when we solve the quadratic equation. Okay, if we have a equation, this equation is 2x power 2, and then plus 5 minus, this is minus x, and then minus 15. So we have this one, we have the equation, okay, polynomial. You see, we use polynomial degree 2. So we have the 2 and then negative 1, negative 15, negative 1 and negative 15. Then what we have is 3 and negative 5 over 2. So we have x equal to 3 and x equal to negative 5 over 2. Okay, so what you can do is you can have negative x minus 3 equal to 0, and we have the 2x is negative 5, 2x plus 5 equal to 0. Then what you have is actually you can do it this way. Then x minus 3, 2x plus 5, the factorization. So some students who cannot do the factorization after we try so hard, then I will ask them to use the calculator and then use this method to do this. Okay, so what we do in the remainder theorem here is actually we are trying doing this one. Okay, that means 3 is the root. So that means x equal to 3. So if x equal to 3, then x minus 3 equal to 0. X equal to negative 5 over 2, then 2x equal to negative 5, 2x plus 5 equal to 0. So 2x plus 5 is one of the factor. Okay, so for this one, they want to show that this is a factor by algebraic division and the factor theorem. So for the algebraic division, we have the x power 3 minus 6x squared plus 11x minus 6. Then we have the x minus 3, x squared. Then we have the x squared, x cubed minus 3x squared. Then we have the negative 3x squared plus 11x. Then we minus 3x. Then we have the negative 3x squared plus 9x. And this one, we have the 2x minus 6, then plus 2. Then we have the 2x minus 6. Okay, so this is a factor. X minus 3 is a factor. But actually, we no need to do the long division. We use the factor theorem. Okay, since x minus 3 is a factor, so x equal to 3. So we have the p3 is equal to 3 power 3 minus 6 times 3 square plus 11 times 3 minus 6. So 27 minus 94 plus 33 minus 6. Okay, so we have 0. So P3 is equal to 0. So the x minus 3 is factor. Okay. We look at the work example 5. It says that this one is a factor of this. They want us to find the value of a and b. So 2x squared plus x minus 1 is a factor. And this one we can do the factorization, x and 2x, 1, 1 plus minus. Okay, because we have 2x here and minus x here, then it will become f. So 2x squared plus x minus 1. So x plus 1 and 2x minus 1 is factor. Okay, so we have the x plus 1 equal to 0, x equal to negative 1. So the 2x minus 1 equal to 0, x equal to 1 over 2. So what we have, it will be property if polynomial, we substitute negative 1, it will become 0, and we substitute 1 over 2, it will become 0. Okay, so this is the equation. So when we substitute negative 1, it will become 0, and substitute half, it will become 0. Then we will get two equations. Then we do the simultaneous equation for the equation. So we have the 2 negative 1 cubed minus negative 1 squared plus a negative 1 plus b equal to 0. Then we have the negative 2 minus 1 minus a plus b equal to 0. And then we have the negative a plus b equal to 3. So we have the 2 1 over 2 power 3 minus 1 over 2 power 2 plus a 1 over 2 plus b equal to 0. Okay, so for this one, um, this will become 1 over 4. This also become 1 over 4. So they will cancel. So what we have is 1 over 2a plus b equal to 0. All multiplied with 2, we have the a plus 2b equal to 0. Because I multiply 2 here, I like to do the multiplication, okay, to cancel out the fraction. So the equation that I will have won't have a fraction. So this is equation 1, this is equation 2. So we have equation 1 plus equation 2, a cancel out. We have the 3b equal to 3, then b equal to 1. Then what I can do now is sub b equal to 1 into equation 2. So a plus 2, 1 equal to 0, a equal to negative 2. So we have this one, then this will become 2x power 3 minus x squared minus 2x plus 1. Okay, so if I want to do the factorization for this one, I can just simply use the calculator to check the answer lah. So polynomial degree 3, 2, negative 1, negative 2, and 1. Then what I have is negative 1 is one of the root. So negative 1 is one of the root. So here we have the negative 1 is one of the root. And 1 also one of the root, half also one of the root. Okay, so for this one, if I want to find the root, okay, it is very easy. What we do to find the roots, okay, this one, there are trick for this one. What I can do, if I want to check the answer, I want to find the root, I can have the x squared factorized in front, 2x minus 1, minus 2x minus 1. I factorize negative 1 for the last two terms. Okay, then what I have next is I have the x squared minus 1. This is 1, and then 2x minus 1. So we have the x plus 1. Wait, I have the x plus 1, x plus 1, x minus 1, 2x minus 1. So this is the equation. Okay.